Hi everybody, this is Nageswara Rao, Assistant Professor of Physics, Government Degree College, Chintalapudi. In this presentation, we will discuss about how can we determine wavelength of light using Newton rings experiment. So in which this is the experimental arrangement in which a plano convex lens is placed on the glass plate P. So where P is the glass plate and a plano convex lens L is placed on the plain glass plate. Then there is a wedge shape of air film is exist at this place, and here there is an air film will be existed. One more glass plate G is placed at an angle 45 degrees to the light rays. If a monochromatic light, that is maybe sodium light, is incident on the glass plate G, partially reflects along the combination of the glass plate P and plano convex lens L. Then these two rays, reflected rays, again reflected at the top of the glass plate P and bottom of the curvature of the plano convex lens. And these rays reflected back and superimpose each other, and interference fringes or interference rings we can observe through the micrometer eyepiece. By using this we can see micrometer Newton rings, it is in circular shape. So by using this experiment procedure, how can we determine wavelength of light? So let R be the radius of curvature of the plano convex lens. Of course it is very large. And lambda is the wavelength of light used. Maybe it is yellow color, sodium light we will use. And dn and db the diameters of the nth and mth rings. Maybe it is, if it is dark rings, we know according to this formula dn square is equal to 4n lambda r. And for the mth dark ring, dm square is equal to 4m lambda r. From these two equations, dn square minus dm square is equal to 4n lambda r minus 4m lambda r. When 4 lambda r is taken as common, dn square minus dm square is equal to 4 lambda r into n minus m. From this, wavelength of lambda is equal to dn square minus dm square by 4 into n minus m into r. So by using this principle, we can determine the wavelength of light, where dn is the diameter of the nth dark ring, dm is the diameter of the mth dark ring, n and m are rings, number of dark rings, r is the radius of curvature of the plano convex lens. So what is the procedure? First of all, the eyepiece of the microscope is adjusted on the crosswise. What is crosswise? In any optical instruments, there is crosswise will be used to determine the measurements. So first of all, the eyepiece is concentrated or adjusted to the crosswire. Now the distance of the microscope from the film is adjusted at the rings with the dark center in well focus. Now the center of the crossfire is adjusted at the center of the fringe pattern as shown in this figure. Now this crosswire is shifted towards the left side. So the counting the number of fringes, the microscope is moved towards the extreme left of the pattern on the crosswire, where it is adjusted tangentially in the middle of a clearly bright or dark fringe, just like this. So this crosswire may adjust at any one of the dark or bright ring. It may be for example, we have to take 20 at the dark ring, or maybe 20 at the bright ring. That is, we have taken as n. Now the micrometer reading of the nth dark ring we have to measure. And thereafter maybe n minus 2, n minus 4, that is 18th dark ring, and 16th dark ring, and 14th dark ring, and 12th dark ring, etc. we have to take micrometer readings. Thereafter, the crosswire is going to center of the Newton rings and again move towards the right side. Then again we have to take readings from towards right side, that is nth dark ring, and n minus second, that is 20th dark ring, 18th dark ring, 16th dark ring, and so on at its right side also. The difference between both sides, that is left side reading and right side reading, gives the diameter of the such dark ring, or maybe that is bright ring. So by using this principle we can determine the diameter of various dark or bright rings, that may be taken as nth dark ring diameter and n minus 2 ring diameter, etc. So when we have to draw a graph, we have to take number of rings on the x-axis and a square of the diameter is on the y-axis. Square of some diameter is taken on the y-axis and a number of rings on the x-axis, a straight line which is passing through the origin. Then we have to draw straight lines at the n and the m. There is mth dark ring touches at the dm square and nth dark ring touches as the dn square. This is dm square, dn square, this is mth ring and this is nth ring. Now from this diagram, dn square minus dm square is equal to ab and n minus m is equal to cd. So that dn square minus dm square by n minus m is equal to ab by cd. So from the previous equation, from the previous slide, wavelength lambda is equal to, we know, dn square minus dm square by 4 into n minus m into r. When dn square minus dm square, we substitute this equation, wavelength lambda is equal to 1 by 4 r into ab by cd. When from the graphical values ab and cd substitute into this equation, we can determine the wavelength of light, where already I told you r is the radius of curvature of the plane of convex lens, can be determined using the spherometer. So this is the spherometer, where the radius of curvature of the plano convex lens using spherometer is r is equal to l square by 6h plus h by 2, where l is the distance between two legs of the spherometer and h is the height of the plano convex lens by measure using the spherometer. So substituting these values into the above equation, we can determine the wavelength of light. This is the experimental procedure to determine wavelength of monochromatic light using Newton rings experiment. Thank you.